live.
Hello, welcome. Great to have you here, and great to be here at the IEEE Internet of Things Google Hangout here. My name's Chris Murphy. I'm editor of Information Week, moderating the discussion here with 4 experts on the Internet of Things. Let me do a quick introduction. Right from the get-go, we'd love to hear your questions. We'd like you to drive the discussion. So at Twitter, we're monitoring the hashtag IEEE for Internet of Things. So IEEE IoT. Tweet your questions. We'll look for those. We'll ask these experts their opinion on your questions. So let me do a quick introduction, and then let's start debating the Internet of Things. Let me start with William T. Webb, the CEO of Waitlist SIG, founding director of Newell, visiting professor at Surrey University, and a member of the IEEE Communications Society. You're joining us from the UK today?
That's right, yeah, I'm near Cambridge.
Okay, great, great. Dr. Kevin Curran, professor of computing and engineering at the University of Ulster, member of IEEE Computer Society, member of IEEE Vehicular Technology Society. And Kevin, where are you joining us from?
I'm joining you from Northern Ireland.
Okay, good. An international panel here. Roberto Minerva is manager at Telecom Italia, chair of IEEE Future Directions. And are you in Italy today?
Yeah, I'm in Curran.
All right, great. And Oleg Logninov, IEEE member, director of market development in the Industrial and Power Conversion Division at ST Microelectronics, founder, CTO of Home Plug Alliance, IEEE Standards Association Corporate Advisory Group, IEEE Communications Society, IEEE Standards Association. Oleg, great to have you.
My pleasure.
All right. Well, let's mix it up. Let's start debating the Internet of Things. Let me just start as a way of introduction. Ask each of you to give me a barrier to the Internet of Things today. We'll talk about potential. We'll talk about opportunities, but I love problems. So let's start with a barrier today to the Internet of Things. Oleg, you want to get us started?
Sure, why not? Well, first of all, we need to ask ourselves a question. What is Internet of Things, and how is it different from everything we know before? And the answer, in my opinion, is quite simple. If you look at closed silos and closed areas of applications, we have seen Internet of Things like systems deployed before. But the problem is they haven't communicated with other applications, with other verticals, with other systems. And Internet of Things is, in my opinion, where we become smarter by communicating with things around us, and things around us start communicating among themselves, making our lives smarter and better and more efficient. So the main barrier here, in my opinion, is that each platform, each thing now has to be able to communicate with many applications, with many verticals. And as a result, we need to learn how to make it possible for things to be interoperable, how they can understand each other, not only at communication layer, but also at semantic interoperability layer. And how do we safeguard data that we don't want to be propagated from one vertical to another? How can we make an intelligent system where thing can communicate certain amount of data in one direction and certain data in another direction? That, to me, is a barrier. Once we can solve it, things will talk laterally and vertically, and that will be the day of Internet of Things.
Great, great. William, how about we jump to you?
Sure, yeah. I think one of the biggest barriers is actually a wireless communication system, which may sound strange because we live in a world where there are myriad different wireless communication technologies. But the problem, I think, is if you imagine you're the manufacturer of a dishwasher, let's say, and you want to connect your dishwasher up, then what wireless technology are you going to use to do it? Are you going to put in Wi-Fi, Bluetooth? Are you going to put in power line communications, 2G cellular, 3G cellular, 4G cellular? Which of those are you going to put into the washing machine? You can't put them all in, the cost would be crazy. So you've got to choose one, but which would be the right one? And until there's one clear, single wireless technology that we use for the Internet of Things, in the same way that we use Bluetooth for personal area connectivity, then I think it's very, very difficult for this to take off in a big way.
That's a great point. That's interesting. Let's see. Kevin will give you the floor next.
Yeah, okay. Policymakers should help identify and reduce all types of barriers to data sharing. That they should ensure that the appropriate technology infrastructure is available. I totally agree about the wireless protocols and also that there needs to be standardization there involved. And the standard dedicated IP stack needs to be adapted to low processing power microprocessors, such as those found in wireless sensor networks. And it also, overall, it has to be scalable. Each of these sensors by themselves may not produce a lot of data, but when we're dealing in the scales that we're talking about at the Internet of Things, we cannot have the Internet of Things bringing down the Internet as we know it. But they have to scale, and there has to be some ways of standardization involved, and literally agreements and what is being shoved out there, because not all of it is useful.
Thank you, Roberto. You got the toughest draw because they got 3 and you can't copy. So what do you got?
Okay. Well, I have 2 more. So I think coming from an operator, I have to see things in a different way. I think we cope with the 2 barriers. So the Internet of Things would be relevant business models, how to make money in this complex environment, and the number of sensors. I mean, from an operator point of view, if you want to manage, if you want to provide services, you have to provide services to a very large audience, many millions of customers. And that makes a lot of sensors that you want to manage. And at that point, you cannot manage the sensor in the usual way. We have people going around the places, repairing things with the cars, That is not feasible. The complexity, the numbers in the Internet of Things will bring in a lot of complexity. And we need to have technologies like cognitive technologies, autonomics, and things like this to help us to provide insurance. The other thing is, since we are talking about big numbers, there is a huge investment in networks, in sensors, in processing devices. So we need to figure out what is the business model related to Internet of Things. Otherwise, big providers will not be able to invest on Internet.
Oh, that's great. Thank you. Thanks for getting us started here. We're starting to get questions in. So the questions are coming into our Twitter feed at hashtag IEEE-IoT. So please keep those coming. First one, it's a great question. What is this is from Ahmed El Murtado. What is the required skills and educational background an engineer needs to compete in the future in such technology? Anyone want to take that one?
Oh, I will. I think Internet of Things is new. Probably we need to really be interdisciplinary. We need to have many skills. And I don't think so far we have a precise profile for saying this is an IoT engineer. You can be an hardware expert. You can be a software expert. You should be also a user interaction expert. One of the things that Internet of Things will bring is if you provide many sensors that are collecting data about the life of people, you will be monitoring them. You will collect a number of data, and you have to present the data in a useful way. It's something that is natural, that is helpful to the people. Otherwise, people will not use this kind of information. So I would say we need to have profile covering the hardware, how sensors are working, to provide new ideas of what to monitor. We need to have software experts because we need to have programmable middleware for creating services and platforms. And then we have to give a lot of attention to user interaction problems. to the user interface. Otherwise, people are not going to use it.
Yeah, great. Anybody else with ideas of other skills that are key in this arena?
If I could add to that, coming from a security background, I would like to see more security skills being involved, people with a background in security, because the Internet of Things really is the connection of devices which by default are remotely connected. And the problem being that a lot of these devices are reduced instruction sets. In other words, they do not have the power of a full PC. Therefore, the problem is a lot of sensors connected to the Internet of Things really do not have the power, the processing capability of running secure cryptographic protocols. So therefore, a lot of these are, it's kind of like get the product out to the market and do security later. But security cannot be added in a lot of cases because these are really just reduced instruction sets, really. So I'd like to see a lot of security experts. And in fact, yesterday I was interviewed by the UK's leading newspaper, the most popular newspaper, the Daily Mail, about the story there, which you might have seen running, where a hacker broke into a baby monitor and started screaming obscenities at a 10-month baby. But we're going to see more and more of these cases coming where people buy devices, they install them, they're not necessarily IT literate, and they use default passwords they're left on, or because they think that the consumer models are the security that they're going to have with their Windows operating system, which does not exist when it comes to small devices which are linked to the internet. So we might see more of these cases again. So I'd like to see, again, coming from a selfish point of view, more security experts involved.
Kevin, before we leave you on that security note, how are the skills? Are the skills going to come from conventional IT security people? Where are the skills the same in IT and this more operational world of the Internet of Things?
I mean, it is. I mean, what you want is, all security nowadays seems to be network security, really, because obviously there's software security dealing with software, not necessarily a network, but network security can be so much more harder because there's more access points, there's more to do. Of course, the bad guys only have to be lucky once, where the good guys, the IT administrators, have to be perfect all the time to keep people out. But really what you're talking about is people who have a good background in network security. Basically understand the protocols, understand how do you access a remote system. Again, and again the software coming into it. I mean, the biggest flaw we've seen of late has been the heartbeat. And of course that was all down to a buffer overflow. So that wasn't to do with actually the network aspects, really. It was a software error, which could happen. But it's just crucial that people really have, that sign up again when they're in college, that they learn proper security and go to the courses and take it on, really. But really, it's network security.
Right. Okay.
Well, I think the area of security is a much broader subject than that, because when we talk about the Internet of Things, we definitely need to be cognizant of the fact that we need to safeguard many things. We need to be able to securely and safely join the device to the network, so it has to be authenticated and somehow provisioned to be a part of this network. But there is something else, security on the links. How do you securely transmit data from one point to another? How do you securely store data? But now, with Internet of Things, since we have a single platform, look into your smartphone. From your smartphone, you derive data that is being served to so many applications and to so many verticals, and with every day it's multiplied. How do we preserve the integrity of this data? So when it's propagated to storage, we actually know what happens to it after it leaves our phone. Just recently, there was a study published that by imperfections in accelerometers in a smartphone, you can actually identify which phone the data was collected from. So how do we create an environment in which we can actually safeguard the identity? How do we want to make sure, if we would like to be remaining anonymous, the data cannot be decoded to identify us, so the signatures can be protected? I think that type of multi-layer data privacy protection brings a whole new dimension to the security, which today has not yet come to the forefront, has not been yet fully explored or even examined from the policy point of view.
Right. Anything to add on skills?
Well,
you're talking about legal skills, you're talking about security expert skills, you're talking about hardware development skills. It's a subject so broad that it's not even possible to account for all of the skills needed to create a comprehensive solution here.
Right, right. William, did you have something to add there?
Yeah, just to pick up really on a point I think Roberto started to make, which was this is such an embryonic area and there's so little certainty that actually some key skills really are flexibility and innovativeness. And I know those aren't skills that you can get a degree in, but for people who've got the ability to see how things are and change what they're doing as a result, are really useful at this stage of the game.
Right, right. The another question that came in, and that is, it's pretty broad here, but a prediction: will the Internet of Things make our life easier, or will it make it more complex to take care of? Where are we headed?
Well, the goal is to make our life easier. When the things will start talking to things behind the scenes and essentially predict our behavior and our needs, that's the ultimate goal of Internet of Things. But we're quite ways away from there. So we'll have some bump.
Well, actually, in Telecom, we did a few surveys with our customers. And one of the points is that many people do not want to deal with technology. They want to have the services of technology, but if you ask them to do a little bit of the deployment of the devices into their home, they would say, we are not interested. We just want to have somebody coming in and deploying the stuff and use the services in the easiest way. So I would say the service provider, the solution provider, have to keep in mind this kind of requirements. People are not technicians here, and so this technology has to become transparent. You have to provide the service in a very transparent way, with a very good user interface, very natural user interface. That would be the success, and that is strongly related to the make the life of people easier. If you are asking very complex interfaces, or you are asking customers to do very complex procedures, you are making that life miserable. If you want to have an example of this, you can go into a website. It's called bwired.nl. It's a prosumer. It's a very expert person. He loves technology. When you ring at his home, he is taking a snapshot of the postman. He's measuring how much water, how much electricity his home is consuming. But that is very technical. You have a very complicated dashboard in this website that no simple person would use. So I think there will be a very strong requirement of simplicity, of making life easy, providing new functions.
I think a good example here to look at is something like the idea of a smart city. And in a smart city, things like the lighting is smart, so it knows when it needs maintenance. It can turn on and off automatically. The parking spaces are smart, so they can tell you where to park your car. The garbage bins are smart, so they can tell you when they're nearly overflowing. And actually, that doesn't impact people at all. All of that stuff is run by the city authorities, but it makes the lives of people in the city better because they can park more easily. They don't have to face overflowing garbage bins and so on. So I think a lot of this stuff won't be directed at consumers. It'll be directed at governments and large corporations, and it'll mean they can deliver stuff that works better. So I'm pretty confident that actually it will make our lives better and will make our lives easier.
I agree, and to follow up, yeah, one of my favorite examples of the Internet of Things is the Big Belly solar power trash can, really, which alerts sanitation crews to when the bin needs emptying. And what they found in I think it was Boston, they found that it reduced the pickups from 14 to 1.6 times per week. Well, something like that reduces fuel costs. It allows the guys to work on other things, and as a taxpayer, it should reduce your tax. So these are beautiful examples of where sensors literally do make our lives easier and can lead to reductions in all sorts of overheads that we generally would. There was no solution before the Internet of Things, really. Before, you could have a device which is remotely connected cheaply, because it's not as if they have to dedicate the lines here. We have an internet we can plug into. And that's a perfect example of devices with sensors, really, reporting back and alerting humans to what to do and how to do it. And of course, we all win in cases like that.
Right. The examples I see a lot in the industrial side of things are kind of like that, Kevin, where there's some sort of alert. They're you need to take this maintenance step. You need to avoid this downtime, and avoiding downtime is a great convenience, right? That it breaks down on your schedule as opposed to the unexpected schedule. So that's certainly a place to look. We have another question coming in from Mark Milliman. How will the Internet of Things impact the Internet with respect to bandwidth and quality of experience? In the U.S., we're experiencing challenges on the regulatory front, offering quality of service for residential services. So if we keep adding elements that may have time-sensitive needs, how can you do that unless you can guarantee quality of service? What's ahead?
Well, I think the question here is not only how does it impact internet, but also what needs to be done from the architectural point of view. Because we cannot rely on the notions that all of the data will be pumped up to the cloud and then transmitted back to the actuators. So we need to find a way how to grow lateral connections among the systems and how to bring the intelligent partitioning of what intelligence needs to be in the cloud and big data and what needs to be done here locally. So I think it's not just an evolution of the Internet itself impacted by the Internet of Things, but also the evolution of our architectural approach to the Internet of Things to make it work. In fact, what I wanted to mention to everybody, I think that is not a more serious subject. IEEE just started focus on studying the architectural approach to the framework of Internet of Things. And I think that's something that everyone should be interested in because not only defining how to keep data, how to penetrate how to architect the Internet of Things, the system of the system, so we intelligently use the data and don't create bottlenecks for the
If I may, the issue of quality of service, it's an interesting one. We did a few experiments in Telecom Italia, and we were considering very simple sensors with aggregators in between, so some gateways, and we made a few calculations. So if you are not transmitting multimedia information, you don't need to have too much bandwidth. And many services can work with the best effort network. The problem will come up when you want to control, for instance, video cameras, when you are dealing with information that is non-multimedia. So you are taking snapshot of your home and you are sending this information. So at that point, the bandwidth could be a problem. The other problem that is coming out is to have something that is transaction. You can imagine certain application like eHealth. eHealth needs to send eHealth application needs to send out information, and this information has to reach a destination because maybe it's an alert, related to a patient. So we need to have a secure transaction mechanism, and that could be related to quality of service. For sure, it's related to quality of experience. For the time being, what I'm seeing is that there are a lot of applications that instead of dealing with e-health, they are dealing with wellness. So best effort it's a good approach because you are not dealing with the life of patient. With e-health application, you need to have a very confined environment, a very secure environment, very guaranteed with redundancy in connectivity and things like this. So I think for any single application, you have a specific set of requirements in terms of the quantity of information that you want to deal with, and even if you are dealing with not that much information, sometimes you need to have a transaction and be sure that your information has been sent and received to the destination.
William, you started off with a concern about the wireless networks. Do you see the quality of service, consistency of service becoming a bigger problem?
It could do on the wireless side, and I think Roberto is basically right, that actually most of these machines are sending tiny amounts of data, so small that it's really going to be less than 1% of the internet traffic, probably less than 0.01%. And many of the machines don't need their traffic to get through in any quick time. If you're the garbage bin, it doesn't really matter whether your reading gets through in 1 second or 1 minute, frankly. So there's plenty of time. The problem, I suspect, will actually be the wireless link. And it'll be lack of coverage, or problems with battery power, or just general capacity issues on the wireless side of things, rather than on the internet itself.
In some of the industrial applications that I've been talking to people about, they are concerned on the next level about bandwidth. So looking at talking to ConocoPhillips, an oil and gas company, they're looking at bringing up data from the pipe, from the drilling pipe, and at fiber kind of levels, hundreds of times of the data they have today. And it gets to Oleg's question, where they're starting to look at how do we architect so some of that really big data analysis happens at the point of collection. So it's to Oleg's point that the architecture really defines that of it's too big, it's too timely. We can't bring that back. We have to do the analysis on the collection end.
Yeah, I agree. I think that's exactly right. That there's a lot of places where actually all you want to know is when some kind of exception happens, something has gone wrong. So you don't need a massive constant stream feed of data, but you do need that data analysed or processed in some way, and then the exception sent back to you. And I think we'll see that there'll be some clever processing at the node to avoid stressing heavily the wireless link. Otherwise, you can start to build in a lot of cost into the system. If you need to send a lot of data back across a wireless link, then that's typically going to add a lot of cost to the solution.
Right, right. We had a couple of questions in about vendors and startups and the like in terms of what we're going to see. One question comes in asking about the open hardware movement and do-it-yourself movement and the like. And basically the question is, who will dominate the market for the Internet of Things? Does this change? Do the technologies involved here, are they disruptive in terms of existing vendors, whether it's on the network, in the data centers? How disruptive is this to the vendor landscape?
If I may, I would like to start maybe with the fact that we're disrupting business models. If you look today at the world of smartphones, what has clearly been shown by Google is that you can provide a lot of services that seemingly become free to the consumer because they compete with other things, such as, for example, data collected from you. One great example recently I came across is an experiment done in Boston. They developed a program which is based on technology coming from one of the startups. And what this technology does, it collects data from smartphones that uses accelerometers to detect potholes on the roads of the city of Boston. So we're talking about a startup taking standard technology, off-the-shelf technology, by exploiting data collection, creating tremendous benefit, and then applying for the potholes like actually national why they have move the market and move the model that it's actually worse if you move other service and data-centric model that has been possible.
Well, look, we're having a little trouble with your audio there. We'll try to adjust it as we go, but so we lost you at the end there. But anyone else have input on that?
Yeah.
Well, I could say that Google will probably win, but I did find it interesting that they did spend a lot of money on Nest. Like a lot of purchases by the giants, I've often been a little puzzled, but I do get Google. Google want to perfect search, really. So therefore, in the future, when you walk into your house and there is a connection with wearables there, even that you walk in and you're a bit cold, but you don't have to do that thing where you bring up your app and you control your temperature sensors in the house. That it will know you're cold because it knows the temperature and it knows that you're shivering a little bit, and it will tell temperature controller in your house to turn up the heat and do it for you. So this ambient intelligent world where again Internet of Things settles in nicely. But that's where they're going with that. They do want to control everything from, to give us this perfect world where we have every information at our fingertips, but also now that they're coming further into our house and they're helping us. And of course, Nest is a perfect example of, a device that does some things and does some things very well. Again, Nest is again, that the home alarm, which also has humidity sensors and weather sensors and temperature and again, really, the jury will turn the alarm off at the way of your hands. Again, there was security implications with that, or they had to fix that. But again, Google are trying to move into this space as well, because it is a nice fit for all the platforms they have and the services that they offer, and that they can see where it is going, where we are moving towards this Internet of Things. We have these devices which help us 24/7.
My perception is actually, first of all, the Internet of Things is so broad. It's trying to pick a winner is a bit like saying who's the winner in the internet or who's the winner in cellular telephony. But what I have spotted is that the Internet of Things is dramatically different from the Internet of People. So machines have got enormously different requirements, hugely different price points. So you pay much, much less per machine per year, and hugely different ways of looking after the companies. And actually, the companies that serve people at the moment struggle badly with the Internet of Things because they don't have the right mentality and the right forces to deal with that. So, for example, the cell phone operators don't tend to do very well because they're trying to apply the same principles to the Internet of Things. So I think actually it won't be the companies that currently are doing well in the Internet. It'll be a different suite of companies, some of which will be startups and some of which will be coming in from outside, but with a different mentality and mindset that will really help them attack this space.
Mm-hmm. Right. Another question. So we're getting.
Oh, sorry.
Question.
Sorry.
Yes, please.
Oh, I think we are a little bit missing one point from my perspective. The question was related also to the do-it-yourself movement. And actually, I think the winner could be the user, in the sense that the capability that are made available now to the common users are so good that people can create their own solution. My 15 boy has a smart board that is providing to him some sensor capacity, and you can control this board with a simple, very simple programming language, the Scratch programming language. That is a programming language for newcomers. And it was very simple to set up this environment and to start developing some application in the home. And this is part of a global trend that I call softwareization. So the hardware is becoming general purpose. You can have a lot of computing power. If you think to Raspberry Pi, a very small boards that will cost a very small amount of money, but if you can put together 128 of those with Android software maybe, and you can build your own application. So I think there will be some clear winner in the industrial internet in business application, but for the residential customer, let's say, it will be a lot personal development of application and things like that. Another point that I would like to make is that, from my perspective, a big giant that is well positioned with Internet of Things is Twitter more than Google. Twitter is actually providing the publication subscription engine. You can use Twitter to collect information, data from different sensors and to distribute the data to different things. So I think they have a perfect machine, and you can do that in an easier way than with respect to Google. So I think under this perspective, I see Twitter a little bit a step ahead of other companies.
Okay, Twitter, good. The another question came in. So speaking of Twitter, we're taking your questions via Twitter at IEEE-IoT, hashtag IEEE-IoT. This question is from Luis Del Bosque. Which communication protocol will be the main protocol for the Internet of Things environment and applications for daily use? Communication protocol?
So I think the answer is there are many different layers to this particular one. There's the lower layer, which is the underlying kind of communications technologies. Is it Wi-Fi? Is it Bluetooth? Is it cellular? Is it something else? And I think the answer there will be there'll be many different ones, although hopefully, as I talked about right at the start, there will be some move to standardize one preferred technology. I think the interesting question is whether IP is going to be used as a higher layer internet protocol. Most people think that it should be, but it has a lot of problems in the Internet of Things. In particular, it's very big and very clunky. So if you want to send 1 byte of information to a machine and you encapsulate it in an IP packet, you've got more like 200 bytes. So you've got massive overheads, which aren't really very helpful. Now, there are attempts to improve this with versions of IP like CoAP and others that try and overcome that. But even those are not ideal. And I suspect there actually may not be a single protocol. Different companies and different solutions will emerge for particular needs. But I'm not sure that actually IP is going to dominate in this particular space. It'd be interesting to see that one.
All right. Any other input on communication protocol?
So I think...
Oleg, go ahead. We'll see if your audio's sharp now.
Let me see if I can hold the microphone. Maybe that will make it better.
That's good.
I think the answer is really it will be many of protocols and technologies used for the purpose because it all depends on what you're trying to accomplish and what fits best. I doubt IP will disappear because IP is a great protocol that has been embedded in many devices and it's convenient to use, and economy of scale is important to Internet of Things. I agree there will be probably other implementations that will simplify lightweight devices, and that makes sense as well. So I think we'll see a huge proliferation of protocols that we know today. I think one thing that we will need to find, and that needs to be discovered pretty soon, is how to accomplish a semantic interoperability among devices that belong to different clusters, different technology protocols. And that's something that hasn't been done yet. This is something that is in works in many groups, many alliances. And once again, that loops back into the architectural discussion we had before. We need to define an architecture which clearly defines how semantic interoperability can be accomplished where it's possible. Of course, it's not always possible, but accomplishing it will fuel the economy of scale.
Right.
Yeah, I'd like to give a shout out to the weightless protocol. Watch this space. I think it'll go places. That there is a need for a slimmed down, optimized version especially for machine-to-machine communication. What I would say, rather than my initial impulse was to shout out HTTP would be de facto there, but it'll actually be HTTPS. It will be secure communications more so that we're seeing on the web itself, that there is a need and an expectation nowadays that companies' websites will have secure communication end-to-end. So I think that we will see more HTTPS communication over, on the internet itself, but more encrypted communication for all the privacy aspects we dealt with before. And I think that governments will legislate for this. That a lot more information will be encrypted than we ever thought possible.
Right. Yeah, I want to move a step further from what Kevin was saying. From my perspective, it won't be necessarily a problem of protocols. It will be more an issue in APIs. When you are talking about the Internet of Things, the important thing, if you want to have success, is to provide programmability of the services. So many people will not be interested in dealing directly with a specific protocol. It could be COPS, it could be other stuff. They want to see interfaces for programming the boards, for programming the sensor and the services. So probably A few protocols will consolidate in order to guarantee interoperability between different systems, but APIs will be very, very important. HTTPS could be a part for providing, let's say, a REST-oriented kind of approach.
A question just came in from Paolo Sabatinelli, and that is, what industries or what are the first fields or industries are we going to see the Internet of Things take hold and really have an impact? Industry predictions?
If only we knew. But my take is actually the first place is going to be the industrial space and in productivity gains. So, for example, a water company can use the Internet of Things to monitor their pipes, to check that the flow rates are good, to open and close valves. And that's easy to do because it's one company, it's all under their control, and they can see immediate gains in productivity if they do that. They need to send out less engineers, or they use less water or whatever. And that's a much easier sell than something like healthcare or automotive, where you've got to get together huge numbers of different players. So I think that'll be where we see it first, although it won't be very visible to many people because it'll just be happening without any real publication or subscriber numbers or whatever. It'll just happen behind the scenes in those sort of companies.
William, so I'm editor of Information Week. Information Week has a cover story coming out of our digital issue. It'll be on InformationWeek.com on Monday, and we write a lot about those kind of examples because we're seeing the same thing where those industrial, it's, as you described, kind of a closed loop environment. It's a clear return on investment. It's what companies have been doing forever. Invest a bit in technology, capital up front, squeeze operating efficiency out on the other end. And so we have examples like I mentioned, ConocoPhillips, GE, Power and Water, as you describe, and Union Pacific Railroad, examples where they're using it, both where we explore what they're doing today and the big potential they see and the barriers to getting the next level. But very much what you say. And another one that came up is the one you cited earlier, and that is city services. A number of you have mentioned municipal, smarter cities kind of applications.
Well, I think we have to look at what is actually happening in the industry by itself in order to identify what will happen with IoT. Because there are some other things that help IoT to be proliferated into the world. Look at the street lighting as an example. We're living through the LED revolution and migration to the LED technology. LED lamps, by design, have already some electronics embedded into it. So it's very easy to imagine streetlights that become more intelligent and also provide us with some monitoring, as an example, environment around them, gas monitoring, some pathogen monitoring potentially, video surveillance, and other things that can be embedded into the pictures. And because we're going through the changeover, it's easier to implement, easier to embed. When you look at the electric vehicle charging infrastructure, that is another inflection point that can create proliferation of IoT into smart cities. When you look at the outpatient care, essentially e-health type of applications, I think it will be a huge beneficiary of IoT world because that will help us.
I'm losing you there, Oleg. Could you hold that microphone up?
Sure. To be in the comfort of our home while actually being monitored by our physicians. So I think we'll see many areas where disruptive change will come not simply because of IoT has arrived, but because other technology enabled a sea of change in that specific industry. And of course, industrial is very tempting for everybody because it's a closed system, it's much more manageable and under control. But we also have to look for where is a sea change is occurring by itself, because IoT may become a component of the new changeover technology.
Well, another point that I want to make is difficult to predict, but I think if you have objects that if you can add a sensor and a little bit of processing and storage in any single physical object, you deeply change the nature of this object. If you have your washing machine with a sensor plus some communication capabilities, maybe it's not anymore a washing machine. It's something else. It's a service. Probably the manufacturers could rent to you the washing machine, you are not going to buy it anymore. You just rent, and you pay per use. So what I'm trying to say is, as soon as you put together sensing, processing, storage, and communication, you are transforming a product into a service. And that will change totally what is going on. Probably there will be a big disruption in many different areas because you are transforming the stuff. You are not just selling one thing, a watch, and you get rid of the user. You will be in contact with your user because he will send to you data, because he will ask for you for services and things like this. So probably it will be the business model behind our societies that could be changed, profoundly changed.
Roberto, really, that data creates, that sensor creates an obligation, doesn't it, or a liability? You could think of it as, well, you knew this machine was going to fail because you had this sensor in here, you had data. Why didn't you tell me? Why didn't you give me? So in industrial settings, we're already seeing that where companies have to deal with the idea of, wait, if I'm collecting this data, what obligations does that create? Well, I'm obligated to provide uptime. So it becomes that kind of service like you described.
Roberto made a very good point before. Who is the beneficiary? The consumer. And that vast amount of data creates a tremendous transparency factor. And I think one of the benefits of IoT will be much more increased transparency and visibility. And look, even today we already know where we have been yesterday, the day before, because it's all stored in our Google Maps, right? And tomorrow, probably in smart cities where we're pretty much all the time covered by video surveillance, we'll know exactly which steps we make. So I think transparency will also propagate into industrial segment. And so that's going to be one of the tremendous benefits of IoT, but also a huge responsibility because now everything we do happens in the glass house.
I do think as well, it is difficult to predict the future. It is possible that home automation becomes a killer app emerges from there, but if I have to predict as well, people's behavior doesn't change that much. And what we've seen so far is this quantified self-movement where people are very eager to share their lives and their activities and locations. And so we could find a killer app in the wearable market, something we haven't envisaged so far, which obviously is, again, a small embedded sensor, long life battery. But tweets, or whatever you want to call that word, just connects us to the internet, connects a lot of devices which are giving off this information, which again on a global scale could have a huge impact. And again, it's not impossible that a wearable becomes a killer app for the Internet of Things.
Right. Another question came in from Tim Swartos, and that is IPv6. How is it being considered or architected into the Internet of Things? No takers?
Well, I'll say, I'm not an expert on IP, but I'll say a few words on that. So when we designed the weightless wireless protocol system, we actually looked at IP and IPv6 and decided not to use it within that part of the protocol stack because it was just too big. So as I mentioned earlier, we're sending messages that are often only 10 bytes big, and we don't want to turn those into 200-byte messages. So we decided not to use IP at all, but instead come up with a system where if people wanted to use it end-to-end, then we would effectively provide a gateway which would translate IP into the weightless protocol for transmission over the radio interface, and it would look like it was IP end-to-end. And what I hear is when I talk to companies like water companies or gas companies or whatever, they don't really care. They just want to be able to connect their sensor together to their core network, and they don't care whether it's IP or whatever addressing system as long as it fits what they've got in their corporate headquarters. When I talk to companies that are entering this space, they kind of believe it should be IP because everything's IP, isn't it? And therefore this must be IP. It sort of makes some kind of sense. But they don't have any very specific rationale for exactly why it should be IP and IPv6. So to my mind, I think it's still unclear exactly what role IP or IPv6 will play in this space. Maybe as it turns more towards the consumer world, it will become more important because there is a stronger link to the internet. But in the industrial world, it seems to be of less interest.
Kevin, you started us off talking about security, raising that concern. We get a question from Timur Webe that, what do you think of the privacy concerns when everything around us is connected? How big a barrier is the privacy element to progress of the Internet of Things?
It should be a barrier, but I live in the UK here, and there's a CCTV camera on every street corner. I don't need on Google Street View or anything. My life is being recorded right now. But of course, it's huge. I mean, it's when the data is analyzed on a large scale. People don't realize really the implications for the future. I mean, right now people say, well, I'm nothing to hide. Even when it comes to the internet, they might say, well, I've got nothing to hide right now. So what they underestimate the algorithms which are capable of being run in the near future, the processing power which increases, as every 18 months. What we'll be able to filter right now, someone right now is typing into a search engine somewhere how to kill themselves, or how to do something strange, and of course that's being recorded somewhere by beautiful servers in the middle of a desert somewhere, and who knows when that will be leaked, when that will be filtered, how easy that will be in the future. So likewise with the Internet of Things, data which seems raw now, data which seems crude, data which seems unsearchable, will become so much more easily searchable in the future, so much more by exponentially faster to do it, and we will see privacy leaks like we've never seen before. And again, one of the biggest barriers, if you go back to IPv6, I used to see some lazy articles saying that IPv6 is the killer app, is the Internet of Things, but really in some ways that adds to the security nightmare. When you have 50 billion devices connected to the Internet, what happens if when the distributed denial of service attacks come in, or the things that we haven't dreamed of in security circles yet. But of course, the privacy is one large aspect. And again, most of us can't get our head around it really, when so much data is being recorded. And when you have sophisticated algorithms which really are able to filter out and uniquely identify individuals on a scale we haven't seen before. What happens when again analysis algorithms at the moment, which are able to analyze what someone is just from the walking pattern? So these things are scary.
Well, coming back to privacy and personal data, I think we need to reason about this. For the time being, if you are interacting with Google, your data pertain to Google. If you are posting photo or messages into Facebook, those data pertain to Facebook. If you are wearing, those kind of bracelets that are taking your activities, they do not usually show you all the activities that you have done. They do not show all the data that you collect about you. So probably there is the need to ask to all the industry to make available to the people their data. You can collect the data if the person says so, but the data should be returned to the person. So I should be the owner of my data. That is one of the things that is also making a big difference between US and Europe. So one first proposition should be make sure that the data do pertain to users. Then it's up to the user to decide what they want to do with those data. I want to share the data with Google. Okay, so in exchange of a few free services, or I want to sell the data for some money. And if you think about Internet of Things, you will be monitored. As soon as you enter into a smart environment, you will be recorded by cameras. You will be monitored when you enter into a building. So every data will be not provided to you, but used by another organization. We have to give back this data to the users and to allow the creation of new applications and to foster a kind of transparency that is promoted by the users. There is an initiative within the Economic World Forum. They say personal data will be the oil of the future. But this oil has to be used in the right way. If you just soil the user with its data, you are not doing a very good thing. You are maybe exploiting for a few things, but you are not increasing the market. From my perspective, I think privacy has to go hand to hand with the ownership of the data and to allow the user to collect all the data and to decide this part of the data will be private, nobody has to see it. This other part of the data I want to share with my friends or with Google or other companies in order to allow very specific service about me or about them.
I think it's one of those things that you have to answer in the specific rather than the general. So if you say to people, are you worried about privacy and the Internet of Things, the answer is probably yes. But if you say, look, I want to put a sensor into a trash can, and that sensor will tell me when it's nearly full, and I'll come and empty it. Now you've got a choice. You can either have that sensor, and we'll reduce your bills by 20%, and we'll guarantee your trash can never overflows, or you can choose not to have that sensor, in which case your bills will stay high and you won't empty your trash can apart from once every 2 weeks. What do you want to do? And I think in that case, almost everyone will say, well, the privacy concerns of whether my trash can is full or empty are pretty slim. I'll take the 20% off my bill and the trash can being emptied on time, please. And you know, some will be fairly easy to solve. Others, like healthcare, are going to be much, much more emotive and need to be handled with a lot of care.
Right.
Well, I would say in any case that probably, I mean, you should say to the user, the right question is, you will pay a little bit less, I will collect some information about you, but I will share this same information with you. That is the right proposition. But if you say, you will pay less, all the information about you will be mine, I'm a service provider, well, I think you are infringing a little bit of the privacy and the big question about how to do it.
Yeah, maybe, but you know, the cellular operators collect a vast amount of information on us, but they never give me the option of seeing what they've collected about me.
Right.
But the thing is, it's the right point that you should be able to, as a user, to turn the dial where you would like to be, completely anonymous or fully exposed. But if you're exposing all of the data, you have to be compensated for that in one way or another.
Well, that's the conversations we're hearing in these industrial environments where people do have a lot of leverage with it. For example, a power company working with General Electric, for example, they own and run the turbine. They decide whether they want that data to go back to GE. GE would like to, so they can keep that power plant up and running. But again, GE understands we need to provide value in order for them to give them that data. And what if they say, well, we'll help keep your power plants from going down, they'll have a good exchange, and they say, yes, it's exactly what you described, William. Yet that's a good deal for me. I'll share that data based on this, and they have a very transparent transaction about the data.
Exactly.
All right. Well, that's a great discussion and a meaty issue to leave us with here at the top of the hour. That wraps. An hour goes quickly here, when you're talking about the Internet of Things. So there's a lot left on the table, a lot of places we didn't get to, but maybe we can do this again sometime. Kevin, Roberto, Oleg, William, thanks so much. This has been a great conversation. Let's keep it going online on Twitter and come back again sometime.
It was a pleasure.
Thank you.
Thank you.
Thanks.